Hello, everyone. Nice to see you. It's cool that I can see you. It's not the major stage, so I can see you. That's great. I'm Martin. I'm from a company based in Kiel called Chroma Experience. We do a lot of product design and UX and UI and also front-end development stuff. And I'm here today with my former colleague.
Also Martin, so two persons, you just have to remember one name. I'm working since the beginning of this year as a freelancer, but full stack. And as Martin already mentioned, we had some projects in the past together, and that's what our talk is about. So we mentioned the talk web components with StencilJS, but the more appropriate term would be custom elements with StencilJS. We will come to that later, so don't be confused that the title slightly changed. And we have some points on the agenda.
Yes. So we want to talk about what are those custom element thingies and how do they work on a conceptual level, how to use them, when to use them, why they are useful, and also, and most important, what are the, from my perspective, most important, what are the major differences between web components or custom elements and the native HTML elements. And from this difference, I think the most arguments are coming for using them or just not using them. This works.
So what are these custom elements? So the custom elements are a standard which is described in the open web standard. So it's an official HTML standard. And what you basically see if you're looking in the source code, you have a custom element, and as the name suggests, you can just name it as it is. So you build an own component and place it into HTML. The implementation of and the styling and the whole behavior is encapsulated in your defined element. So you have no runtime, no framework runtime running in the background, which is needed. It's natively supported by the browser. And today, I think we have 99% of the browsers which are supporting it. I think the only one which is not working is IE, which is not a browser anymore. So, but that's another story. So that's the core benefit of that. So no Angular runtime running or something in React. So directly native supported by the browser. And the main concept, which you already know from HTML, are adopted in custom element. They apply also there. And an alias for this component or for this element is also the web components. I think on the early draft it was named web components, and in the specification it's named custom elements. But it's really native and standardized technology.
Why could they be useful? That's I think one of the most important questions when starting with this topic. Should I invest time into this or not? It heavily, as usual, depends on the use case. Is this technology useful for me or isn't it? So, as Martin already said, there is no runtime dependency, but besides talking about what is a custom element, it's also worth it to spend some looks into what it is just not, and it is not something comparable to a full-featured web application framework like Angular, React, or something like this. So it's just the UI component, nothing more. You can also encapsulate business logic in those components, but there's no support for this. You need to build this on your own. So what's the major approach is building UI components and deliver them to provide native supported technology as the UI components. And the most important topic is because there are no relationships to any kind of web application framework or situation, you can use them in addition to your web application framework, and you do not need to select a specific one. web components or custom elements play nice with others. One more topic coming from that context, if you imagine you build your UI components you need for your web application using custom elements, they are completely separated from the rest of your application or your applications. So there is a natural boundary between something we call the presentation layer, so the interface the user is interacting with, and what is going on in your application. Mostly it is business logic, API integration, stuff like that. And this clear boundary is something we think is really useful to have this strictly separated. But I think we both have a very strict approach on front-end technology and front-end architecture, so maybe other people would say, sounds heavy somehow. What is also coming with custom elements is a strict encapsulation of what is going on in your custom element. If you wanted to have it like this, you can make sure you have the full control about the interference of CSS or interference of JS context with what is happening in your custom element. This is also strictly separated, and it is not separated by the way you implement it, it is separated by design. So usually you can avoid those crazy CSS cascading side effects, changing the CSS of one component and your whole application is going crazy because everything is inheriting from something, or you have duplications in CSS class names or whatever. It is easy understandable as a concept because it adopts the full HTML native component ideas of styling, of behavior, of especially the event system, of giving your components some attributes that can be used within your components, things like that. So you do not need to start from scratch understanding the concept if you got the concept of native HTML components. In addition, especially when it comes to attribution, something that's often really useful is, I don't know, let's say you have a specific UI component and you want to pass in, because you are using this UI component, let's say in the React context, you want to pass in the value coming from an enum set. That's not possible with native components. You can just pass in some string and fingers crossed, you are talking about the same stuff. The same goes with, let's pass in some object as attribute. You need to serialize it and later on get it back and deserialize it, things like that. With custom elements, it is possible also to use non-scalar values as attributes, which is pretty helpful if you're building higher level components that are just not, when it's not feasible from the semantic perspective to attribute them just by strings. And from the nature of web components, what is going on under the hood, one of my favorite benefits is there is really insane render performance coming from the use of web components. Why this is like this?
Yeah, then we talk about the difference between the custom elements and the native elements, how it is working. So we have to step a little bit back. So basically we have a separated DOM tree for each element. So if you add a custom element on a regular basis, usually it has a separated DOM tree. So that's the shadow DOM called. We come to that a little bit later.
It's a native DOM tree. That's very important. So there is no virtual DOM or something like this.
No, no stuff generated by a framework. It's natively built into the browser with all the features you're having, but it's isolated in the regular tree. So that's also where it comes into place when it comes to the style overrides. It's isolated by default. You can change it, but that's one of the topics we also cover later. So that's controllable within your component. That's a real benefit. So we don't have this issue that other elements and another tree or node in the tree can override your elements in your DOM tree. That's so you can really encapsulate it. And you get native change detection by the browser. So you don't have to build something like in Angular, you have the change detection to get changes in form fields back, vice versa, have the changes, event stuff. No, you have native support for that in the browser. No runtime, it's natively built into the browser.
The browser makes the decision whether to re-render this, especially this DOM tree, or whether it is untouched because it's isolated from the rest. The browser can do this with a very high performance.
That's also the reason why it is so fast, because it's an isolated context and makes it easier for the browser to decide, is it changed? Because the browser is basically just a render machine. It's all about rendering content. So that's the basic idea of a browser. So, and in regular HTML, the browser has no clue what is the dedicated element, which is isolated from the whole layout. But with custom elements, you have the control over that, and the browser can also see what he has to update. That's why the performance is so awesome at that point. And you can also say, okay, from the outside, I cannot override the styling. So you can encapsulate also the styling there so that it's not cascading. Stuff like that you can do with custom elements. The same for the JavaScript context, that you cannot access the context outside the custom element. So you cannot just go into and in the DOM and manipulate the data there. No, the only way to manipulate the data is via the API you define in your component. That's why it's really important to think about what's the contract of my component, what are the attributes I'm using there to make sure that's fitting all of the use cases you want to have in your custom element. And you have also the native support for custom events. You can define events, listener you want to have, that you say, okay, if something happens in my component and the outside surrounding needs to be notified about that, you can add custom events for that and get back the data. But it's native browser event, no framework flavored event stuff where you have to mock, add stuff and all the stuff. It's like a normal on-click event. So.
And you have control over whether this event is cancelable, whether it should bubble through the DOM upwards or not. This is one of the supported native concepts of HTML in general. One addition when it comes to encapsulation of CSS, you can manipulate what is going on inside the component, but the inheritance or the cascading of CSS in general is inverted. So usually you define, let's say, on your top level, you define that a specific class should have those properties or those render instructions. And way down your tree, you extend this class by some more information. And in this concept, it is somehow inverted. So you define the styling in your component, but you can override the basic styling from the outside, which is usually not possible without crazy important stuff and things like that. But so the basic idea is you define your custom element and it is bringing in its default styling. And then you can just, I don't know, in a theming situation or something like this, you can inject additional CSS from the outside.
Yeah, that's basically the light DOM. What we have. So the regular DOM you're knowing is named light DOM. So just that you heard of it. So we have shadow DOM and the light DOM. What you normally have in HTML is DOM from the naming. And you see on the left side our HTML, and on the right side you see then the representation on the different nodes. And if you change one of the nodes there, the browser normally just re-renders all the stuff, because it's one tree for him. He cannot decide where's the change. Maybe the layout changes in the list item leads to a height change, so that he has to re-render the whole page because the layout changed. So you will trigger a re-render. That's why you have sometimes in frameworks the problem that the page is completely re-rendered and you run into render issues because it's only one tree. And there then comes the shadow DOM, where you see basically you have a sub node there, the shadow tree, which is inserted into the overall DOM tree. And then you have a nested structure within, but it's encapsulated within the custom element there.
Yeah, right. On the right side, you can see this. This is very important. We are coming to this later. On the right side, you see the usual document tree. This document tree is then the light DOM. And within this document tree, there is this one green circle called shadow host. This is the one node containing the shadow tree. And in between those two DOMs, there is something called shadow boundary. This is very important because on this boundary between the two DOMs, there are some rules you need to know to be able to fully get the concept and also to make use of the concept. The shadow host in this example is directly the body, which is hosting our custom element. That's why it's called the shadow host. The shadow tree is something you cannot see from the outside. So the light DOM has no knowledge about this shadow tree. There is some boundary in between what's happening inside. Doesn't matter and doesn't play a role for rendering this whole document tree. If this shadow host is changing, then there is a re-render going on. If changes are only happening within the shadow tree, then they are only performed, the re-render is only performed within this shadow tree. The shadow root is just visible from the inside, which is the host element itself. The custom list in this example is acting as the shadow root, and all the child elements of this custom list, maybe they are not injected in here as child nodes, but within custom list, this custom list element can render whatever it wants. It has its own tree. It can render its own children, have its own styling, triggering or exposing its own custom events and things like that.
Yeah, and the main challenges is that you have now to deal with all the stuff in the custom element. So when you normally use HTML, the browser vendor already built in the behavior. What is the HTML looking like? What it is doing in the inner functionality? If you build custom elements, you have to control the whole life cycle. So when the component is initialized, you have maybe to load data and update data, create new elements regarding if you have list entries, add more entries there, stuff like that. So if you are using frameworks like Vue.js or Angular, you might get the feeling, oh, it looks similar or feels similar, like in these frameworks. The idea is the same. The main difference is that it's executed directly in the browser. So it's no glue code in between. It's built into the browser. But you have to care. So it makes it adds complexity on the building on the components there, because you have to care about. So that can lead to the experience that you add a custom element on your page, on your application, and you see first maybe a blank area because the data is just loading. So you have to deal with that. Maybe you add a shadow there, a loading indicator or something like that, blurring, whatever you want, but you have to deal with it. You have a life cycle, you have to take care of it. You also have some restriction what you can do with the events. That's also important when you use, for example, forms. So if you want to have in a web application input fields to control data, you have to take care that you are restricted how the events can go up into the tree. So there are certain restrictions which prevent from bubbling the events more ahead in the tree.
That's going on this shadow boundary. So we said this shadow tree stuff on the right side, especially the shadow root, can expose events and trigger them. And those events could bubble up the DOM tree. Most of the regular events are able to pass the shadow boundary. So if there is a click event happening in this shadow tree on the right, and you have a click listener on the left, this event is bubbling through the DOM, over the shadow boundary and up the light DOM until there is someone listening. This is not happening, for example, for on-input events, which you usually use if you want to to be informed about the input that is happening on an input type text element, for example. This is not working. So there is a list of events that are not able to bubble over this shadow boundary. That's why we had a lot of trouble dealing with this when it comes to using Angular together with web components and using all the crazy magic stuff that's built into Angular when it comes to form handling. If those, for Angular, necessary events are not able to bubble over this shadow boundary, this whole concept is not working. What you can do to avoid this is you can decide to not use shadowing for specific custom elements. It's part of the specification to just have a custom element with all the benefits coming from custom elements, but without this shadow boundary. This comes for sure with a price. The price is there is no shadow, there is no shadow DOM available then. So you lose the benefits of encapsulation, but with that you always, or you can get some benefit when it comes to events, and sometimes it's easier to go with no shadow DOM, but have the support of the, I don't like Angular, have the support of the framework more or less out of the box. So our talk is called Custom Elements with Stencil. We didn't talk about Stencil because Stencil isn't playing a big role into the results coming from custom elements. As we said, Stencil or web components in general, custom elements in general, are not comparable to some kind of framework. You can do whatever you want with your custom element, but there's no framework behind, so it comes with no runtime dependencies. That's why Stencil is not something like a framework. It is just a tool stack to benefit from modern web technology while building custom elements. That is basically it. It's very well documented. The whole ecosystem around Stencil, Stencil is a part of the whole Ionic ecosystem, is very healthy in my opinion.
Yeah, as you notice when you're using the framework that it's done by a team which already built several components or component library. I mean, these guys from Ionic built already Ionic for the web application, for hybrid web applications. So they have a lot of experience what developer really need in that case. So they started off Stencil. After doing that, with that in mind, you're already focusing on the important parts. So you think about what is a good API for my components, how you want to have the different build targets. So for example, Stencil adds support with wrappers to integrate with Angular, React, and Vue. So the basic idea is you write your component once with Stencil. That's a standard web component which got built. And then the team around Stencil is already adding some vanilla scripting around that you get direct support for Angular, React, Vue. We'll show it later on an example how this works on the schema side.
Maybe I already saw some signs over there. We are running out of time.
Yeah, so that you really see there, and you have a really good support. What you get out of the bundle is support for development environments. So the bundle you're getting generated already have all the integrations in the IDE that the users of your component get full IDE support, auto-completion, documentation, edit, stuff like that. And you can focus on coding your standard components. That's the really important part about Stencil at this point.
Including testing, so unit testing as well as end-to-end testing. You can generate the documentation from your custom element code. Stencil makes use of TSX as well as SCSS. You can extend this by the tools you prefer, like, I don't know, less or whatever. There are some Stencil alternatives. I don't like Angular elements. I don't like Svelte. I don't like Preact. Lit element could be something
like a lot
useful.
of stuff.
I don't like most of the things. So Martin prepared a demo. this, Martin?
Yeah, maybe we can. You can look at the demo later. The basic idea about that one is we have a library set up, a demo application set up. You find it there on GitHub. We have the core element, which is basically the web component. So you have a library there. It's one folder there where you have all the typings, the bundle, all the stuff already added. And then you have an addition NPM package, which you can just give over to the team, which is using Angular. And you have a React package, which you can hand over to the React team. And it has all the stuff included to be ready to use. And in the core, they are reusing this core dependency where the web component is. And the stuff which Stencil is doing is adding, for example, on the Angular side, the ng model around, the wrapper to load and init and map this lifecycle around. You don't have to do it. It's done. You have to to a certain extent, make some configuration changes when it comes to one of the form fields that you have listed, but it's really only a small portion. The benefit is that you have a really standard way for the implementation. Yeah.
This is a crazy good question. Most of the people making decisions on whether to use this or that or something else are not asking these questions because they know the answer in beforehand. It is usually not a sustainable decision. This is something totally different with custom elements because they got part of the HTML specification. They are here to stay. So changes on that are usually, which lies in the nature of the web specification, are here to stay. Support by major web frameworks is increasing. I think with the latest React version 18, they promised us to support custom elements out of the box. I didn't try this, but I will. Stencil is a really cool tooling to build web components. It's a lot of fun. It's understandable. It's clear. What is totally crazy for me as someone mostly using React is there are different hooks for lifecycle events. This is so much fun. And there are coming organizational benefits from the use of custom elements to build UI components for applications. The separation between this hard separation by design between the presentation layer and the business layer in an application is something that's really worth it to invest this little amount of time into learning this technology, which is really not a steep learning curve.
Because the UI or the guys with the UI UX experience can focus on really implementing the look and feel of the components. And you can add later in the development team add the business around, the business logic in the front end. So you don't have to care about the CSS styling. You can just use the component which is already provided to you. That's the basic idea. So you have a natural cut in between. But you have to keep in mind that you have this cut there, which is in most of the cases desirable. But you have to keep it in mind.
I can bet most of you working in the front end field somehow we're stepping into some code base and figuring out this is a UI component, but why the fuck is there business logic implementation in this UI component? And this is something that could not happen if you haven't not only this cut by, let's say, rules the dev team gave itself, but by a clean cut supported by technology. It is just not possible to put business logic into a UI component if this UI component doesn't know anything about the outside world.
And this also leads to typical use cases where you can use it. So where you have the separation between UI and business logic, especially for larger teams where you have these cases, organizations which have a lot of products and use it in the same look and feel in different products. So they also benefit in these use cases. And
maybe those products are realized using different web technologies.
Yeah. Then you run into the issues. You have to replicate the styling in each of the team again and again. So each of the team has to have a really good UI UX experience to make the styling look and look like the design wants to have it. And that's often a big issue. And even if you have mixed front-end stacks Or imagine you have to provide an SDK that somebody is, so you have a customer and the customer of you wants to use a component of you, so a login screen or something like that. So if you have to support 4 or 5 frameworks, you have to build it again and again. With Stencil, you build it once and can just give it to the customer, load the component, and you're free to go.
Yeah. You said this. That was right. One more point I wrote down in here, systematic design approach. We at Chroma Experience are working a lot in the field of design systems, or as we call it, systematic design approaches. And in this field where you try to create a design solution without knowing each and every use case beforehand, it also makes a lot of sense to just concentrate on components and composition of multiple components and how this is working in a very systematic way without really building some kind of application. So in this situation, we often make use of this because in beforehand, we don't know, for example, based on which technology an application will be built in the future by our customers.
When we first used Stencil, we started after some iterations in a really good working mode for that. So we sketched out component, just the API with no styling at all. The design team started building the styling around. The front-end team really started implementing logic, but we had no styling. We have just the pure rendering, so no styling, no real functionality there. And we just updated the package after all. And then magically the styling was fitting. And we just agreed on the contract by the design of the components, where we decided, okay, these are the attributes we want to have. They started designing all the needs, make iterations on their side. We started iterations on our side. It really works out at the end. But you have really to take care about the contract, the same as you have with front-end and back-end. You have to agree on a content, how is the communication is happening. Yeah. And sometimes you break even stuff there because you realize, okay, this attribute doesn't give out all the information we're needing to make the display happening.
Needed a different typing or whatever. But yeah, this is also one big benefit. If you, in general, that's not related to custom elements, but if you think of UI components and their usage more in terms of an API description that is exposed, or an API that is exposed by your UI component, you can do exactly that. Define an API for each component expressed by the attributes you use to incorporate this UI component. Then you can do this without any styling. It's just describing the pure functionality.
So as we already
What's the time?
Exceeded a little bit our time,